All right, here we go. Section 1.4. Here's your goal number 1.
Oh.
It is to write a function rule. That is our one goal. Goal number 2 is to understand relationships of quantities in a function. I am going to go over some vocabulary words. If you know it, raise your hand and I may call on you, okay? All right, first of all, let's start with the word relation. Relation is a set of ordered pairs that shows the relationship between two different quantities. So this is a set of ordered pairs. Does everybody know what an ordered pair is? What is an ordered pair? Anybody know?
Oh.
Yes.
It's like when you graph like the x and the y.
Yeah, exactly. So set of ordered pair is your x and y coordinates. But a lot of the times in our situation, we actually have meanings for x and y. So let's say age and height would be a set of ordered pair. That shows the relationship between age and height. That is a relation. Okay, it's a set of ordered pairs, a set of data. Okay, it's a collection of them. So I can say, here's an example of a relation where I have an ordered pair. 1, 2, right? 4, 6, 7, 9, right there. That is a relation. There's a relationship between x and y, or whatever those numbers represent, whatever the two quantities are. That is a relation. It's a set of ordered pairs. Okay? So then some of the ordered pairs or relations is a function, but not every function, every relation is a function. So can somebody have an idea what a function could be? Yes, ma'am?
A relationship between two variables.
It is a relationship between, I'm going to say between two quantities. Between quantities where, and there's a condition where you have to know, where every input there is exactly one output. So for every input, there's got to be exactly one output. If you have more than one output for an input, when you plug in an answer, a number in and you get an answer, it's not a relation. So in one of our classes, we used an example for a cup of coffee when we buy something at Starbucks. Let's say you get a mocha frappe and they charge you $5. And you go in every day and you get charged $5 every day, right? Same mocha frappe, $5. But let's say one day you go in and they charge you for the same drink $6. So for that same drink you have second or different price. That is not a function. It has to be exactly the same price. Or it's me going in, I get that same drink for $5, and then Autumn goes in and she gets the same drink and they charge her $4. That's not fair, right? So that's an example where it's not a function. So they got to be consistent. For every input, you got to have exactly one output. That's what makes it a function, okay? So then we also have what's called a function rule. Now another word for a function rule is an equation. But it is an equation that is a function. Okay, so this equation have to meet this condition where for every input you get exactly one output. Not every equation is a function. So this is an equation that is a function. So let me give you an example of an equation that is a function rule. So an example for this one will be y equals 2x. This is a function rule. It is an equation. And the reason why this equation is a function rule is because every x I plug in, how many answers do I get? If I plug in 1, what's my answer? 2. Do I get any other answer when I plug in 1? No, I get exactly one answer, which is 2. So that's why this equation is called a function rule, because for every input you plug in, you're going to get exactly one output. Okay? Not every equation is like this. So I drew a picture here that was here. This equation right here on the board, x squared plus y squared is equal to 4. That is an equation of a circle. This is an equation because it has an equal sign, right, with variables and numbers, right, and operations. But when I graph this, when I plug in an x value, when I plug something in here, I'm going to show you how many answers you're going to get. This is an equation of a circle with the center at the origin. Here's my center, here's my x, here's my y. And when I plug in, here's 1, it has a radius of 2, so here's 2, 1, negative 1, negative 2. And then this is negative 1, negative 2, 1, 2. So when I graph this, I get this circle. I get that circle. And if you notice, when I have that circle, when x is equal to 1, how many y values do I have? How many y values do I have?
2.
2. At x equals 1, I have 2 answers, 2 different answers. Guess what? That's not a function. This is not a function because that one x value gives me 2 answers. So this is not a function. Okay? But if I had an equation that looks like this, y equals x squared, that is an equation of what's called a parabola. Okay? It looks like this. At x equals 1, guess what? I get exactly one answer. Y is 1. And then at x equals 2. How many answers do I get? 1. I just hit one y value. There's only one y value that goes with that. See, in this one, I add x equals 1. There's 2 y values. At x equals 0, guess what? There's 2 y values. So not a function. This is a function. So everybody understand the difference between what is a function and what is not a function? So not every equation is a function. So function rule is an equation that is a function. So that's right there. Okay? Any questions about relations, functions, and function rule? Okay. All right? All right. Draw me a little table, please. Just a little one. Everybody know what this table is, right? You've seen these tables before? When you're graphing? Right, you make a table? Okay. This side of the table, we call this independent variable. This is the side you control. Okay? So, on this table, instead of x, I could say, okay, this also could represent number of tickets. Right? I could write, instead of x, I could write number of tickets. Like you guys are going to Apple Fest and you want to ride, you buy tickets, right, to ride? Isn't number of tickets that you buy you control? And then they'll tell you how much it costs, right? So what you control is called the independent variable, which is your x, like the number of tickets. On this side is the dependent variable. Dependent variable. Okay? Dependent variable is the output. It's the y value. It's the result of. So dependent variable depends on what the independent variable is. Okay? So in this case, if I buy number of tickets, guess what? The cost depends on the number of tickets. The cost is an example of a dependent variable. So dependent variable describes your output. And independent variable describes your input, where number of tickets is your input, cost is your output. Does everybody understand? Now the numbers that go here, X values, those are your X values. Or we call those inputs, right? The actual numbers are called domain. Okay? Actual numbers are called the domain. All right? Domain. And the Y values, or your output, these actual numbers that you list over here, those are your range. So domain and range are the numbers. Independent variable and dependent variable are the descriptions for those numbers. Okay? And independent variable is what you control, and dependent variable is the result. Okay? Dependent always depends on independent. That's why the word dependence there. This depends on this. Okay? Any questions so far? Because we're going to be identifying independent variable, dependent variable, domain and range today. We're good so far? Okay. All right, ready for examples? Okay, so we're going to go through examples. We still got a lot of time left. I think I'm going to give you 6 problems tonight, but I'm going to do one of them with you, so you're going to end up with 5. Is that okay? All right, so here's example number 1. Yep. Example number 1. We're going to write a function rule. Right? Because that was our first goal. Write a function rule. Write a function rule. That means we're going to write an equation that is a function. Let me give you a table. Number of hours. And then we have total miles. Okay? Number of hours are 1, 2, 3, 4. Total miles are 60, 120, 180, and we got 240. Now, in this situation, when I look at this, my independent variable, is it okay if I said it's IV for independent variable? Mm-hmm. Independent variable is what? Yes, ma'am.
Is it 1, 2, 3, 4? It's not?
What's my independent variable? Yes, ma'am.
Total miles.
No?
Number of hours.
Number of hours, right here. This right here is your independent variable. Number of hours. Okay? My dependent variable, and I'm going to use dV, and Autumn says
Total miles.
Total miles. So when I ask for independent variable or dependent variable, you are giving me a description for the numbers that, so it's right here. That's where it's going to go, the descriptions, okay? Dependent, excuse me? Total miles. This side right here would be the total miles. Oops, sorry. Now let's talk about, now remember, domain goes with the independent variable, domain. Domain falls right here. Domain are the actual numbers. So when you do the domain, you write the word domain and you do the little bracket, and you can use a square bracket if you want, if you can't make that symbol, okay? And you just list all the domains in that bracket. Amy, what are my domains?
1, 2, 3, 4.
Yeah. 1, 2, 3, 4. That's my domain. Okay? Because domain goes with the independent variables. Those are my inputs. I put 1, 2, 3, 4 into this problem, and this is what spit it out: 60, 120, 180, 240 miles. So now for the dependent variable, my range are what?
60, 120, 180, and
Yeah.
240.
60, 120, 180, and 240. Okay? Those are my range. So does everyone understand the difference between independent variable, dependent variable, domain, and range? So domain and range, you're actually giving me the numbers. Independent variable and dependent variable are the actual description for those numbers. Okay? All right, now we're going to write a function rule. So I'm going to come over here, I'm going to define some variables. I'm going to define. I need a variable to represent number of hours. Okay? Eliza, what do you want to use for number of hours? Sure. H for hours, right? So H equals number of hours. Okay? And what should we use for total miles?
T.
T. T for total?
Yeah.
T for total miles. Okay? So what do you think this equation is going to look like? Yeah. And when you do write your equation, you always do the dependent variable equals something you do to the independent variables, because you're going to do the calculation. This is going to be your output. This is your input, right? So it's always dependent equals whatever you control and what you plug in and you calculate. So in this case, you do T equals, and we're going to do something to the hours. Looking at the pattern. Let's look at the pattern here. For every hour, how many miles do we travel? 60. So the speed that you're traveling is 60 miles per hour, right? So T would equal what of hours? What do we do with the 60 and the H? 60 times H, so we write it as 60H. So for every 1 hour, 60 times 1 is 60. For 2, if I plug 2 in, 2 times 60 is 120. And then if I put 3 in, 3 times 60, 180. So you got to double check to see if this calculation is correct. Okay, so a lot of times it's T equals whatever I do to this, so it'll be 60H. So now I rewrite it like this. So you could do it either way. Okay, any questions about writing a function rule? We're good? Okay. I think what I'm going to do is, here's, example number 3. Can I skip to example number 3?
Yeah.
We're going to you see how we identified independent variable and dependent variable from the table that was given? I'm going to give you a sentence, and you're going to identify the independent variable and dependent variable from the sentence, okay? So it's going to say identify independent variable. Oops, I didn't finish writing independent. And dependent variable. Okay? Ready? There you go. Suppose you want to find how much gas a trip will take in a car that uses 1 gallon of gas to go about 18 miles. So I'll give you a second to write that down. In that sentence, I want to know what is your independent variable and what is your dependent. Okay? So suppose you want to find out how much gas a trip will take in a car that uses 1 gallon of gas to go about 18 miles. Everybody have an answer? Write down your answer on your paper, and then we'll check. I know Trey said I'm going to call on you, Trey, so be prepared to answer, okay? So we're looking for the independent variable, and we're looking for the dependent variable. That's what we're looking for, independent and dependent. All right, Trey.
I believe that the independent variable is, wait, how many miles you go, and then the dependent variable is how much gas you use.
Everybody agree? I agree. I agree. Because we're trying to find out how much gas. So you control how far you're going to travel, right? So you control the miles traveled. How far are you going to travel? Then, if you know that it takes 1 gallon for 18 miles, if you know the miles, guess what? You can figure out how much gas, right? So the number of gallons of gas depends on the miles you travel. So independent is the miles traveled, and then this will be the gallons of gas. And that's what we're trying to find out anyway. How much gas do we need? Gallons of gas will be your dependent variable. I'm going to give you one more, and then I'm going to have you try this one. This one, you could just listen. You don't have to write everything out. Just give me the answer on your paper. Are you ready?
Yeah.
All right. Am I writing too fast? Am I going too fast? Okay. All right, here's another one. I'm just going to write an example. Here we go. Cooking time is about 20 minutes per pound of turkey.